All right, now we've had a little bit of a conceptual overview of NumPy. Let's get hands-on and start to write some NumPy code. So I'm going to follow the little workflow that we've kind of set up over the past few lessons and sections. Start off in a terminal, and I'm going to change directory into this little folder that I've got on my desktop. Yours may be stored somewhere else. So cd/ml course. Now I've got a folder in here called sample project, which has my environment. You'll want to change into the same folder that contains your environment. Hit enter. Now we're in the sample project folder. Beautiful. And we're going to check using conda env-list where our environments are. So I can see I've got one here. I've got a few. Currently base is activated because I've got the star, but I want this one because that's in my sample project folder. So we're going to type it out. You could copy this and do conda activate this here, but we're in the practice of writing things for ourselves because I want to get as used to as possible, writing as much code as possible. ML course, sample project. Now remember, you'll want to change yours to wherever your environment folder is stored. Activate. The first thing we notice is that this has changed from base to our active environment. And now the next step is to create a Jupyter Notebook, our favorite workspace tool. Let's load that up. Now this will open our browser. We brought to the Jupyter dashboard. It's nice and zoomed in. Excellent. We've got our folders here and files that are within our sample project folder. Yours may be a little bit different, but we can see, in my case, I've got the Introduction to Pandas notebook, the example notebook from before, my environment folder. We're not worried about these. We're going to start a new notebook, Python 3. First thing we're going to do is rename it to Introduction to NumPy, because that's what we're working on. Hit enter, and we'll save that. When we come back to the dashboard, we've now got Introduction to NumPy running. Beautiful. Now the first step for using NumPy is to import it. Import NumPy as NP. Now NP is just short for NumPy. If you see this abbreviation somewhere, you can probably safely assume that it's referring to NumPy. It's just to prevent us from having to type out NumPy every single time we want to use a command. We'll hit Shift and Enter. Beautiful. Now in this section, we're going to be focused on NumPy's data type and attributes. So that's what we'll create a little heading because we are in the business of making attractive and communicative notebooks. Data types and attributes. We'll hit Escape and M to turn it into a markdown cell. Wonderful. Data types and attributes. Now, data types as a plural is kind of a lie because NumPy main data type is ND array. It's only really got one data type, so everything you see in NumPy is likely an ND array, and this stands for n-dimensional array. And an array can be almost any list of numbers you can imagine. And n dimensions means the list of numbers could be almost any shape that you can imagine. But rather than talk about it, let's create it. So A1 for array1, we'll create a sample array. Now you can do that by going numpy.array, which just means access the array function from NumPy, which we've imported as NP. And to build an array, which is a list of numbers, we want to pass it a list of numbers. So let's do that. And then to see it, we'll type it again, Shift and Enter. Excellent. We've got our first NumPy array. Now this is exciting. Let's check the type of it. NumPy.nd array. Wonderful. So that's the same as here. Remember, this is just n-dimensional array. Now, for some more examples, let's create a few more arrays. NP array. We'll type out this one. This will have 2 brackets. We'll see why in a second. Now we'll separate it. We'll go to another line. 1, 2, 3, 4, 5. Actually, let's make this 6.5 and this 3.3. So we've got some floats as well as integers inside NumPy. There we go. We might make another one called A3 NP array. And this one we might actually do 3 brackets. So we're getting a bit adventurous here. We'll make this 1, 2, 3. Let's go all the way up to 18. Bear with me. Type along if you can. 5, 6. And then we'll go 7, 8. We want to make sure it looks all right. 9, and then we'll leave 2 brackets here. Or actually, yeah, 2 brackets. That's correct. I'm just counting the number of brackets. You'll see why this is important in a moment. We're just typing out the numbers from 1 to 18 in a very kind of cryptic format at the moment. 13, 14, 15. We've got a little bit more. 16, 17, 18. My goodness. We made it in the end. Let's see if this cell runs. Beautiful. If in doubt, run the code. Now, why would we do that? Well, let's have a look at these 2 arrays. A2. There we go. We can see that. We've got 2 sets of brackets here. And we've got 2 more here. Now let's have a look at A3. Ah, okay. Now this one, it's kind of come out the exact same way as we've got here. Now before we get any further and check out some of the attributes that these arrays have built in, let's have a look at the anatomy of an array. So this is the anatomy of a NumPy array. This is A1, the one that we've just created. This is A2, and this is A3. There's a reason why I put in these numbers here, so we can exemplify the kinds of shapes of different arrays. Now this is very important in machine learning because oftentimes with a machine learning algorithm, your main focus will be making sure the shape of your data that goes into a machine learning algorithm lines up with the other data that you're putting in as well as the output. But we'll see that in future sections. This is just learning the shape of different NumPy arrays. So we've got 1 here, so there's 1 row and 3 columns. So this would be shape 1, 3. Now this kind of data here is referred to as an array or vector. A vector is just a one-dimensional array. If we go to this next one, which is A2, we've got 2 rows and 3 columns. So this one has the shape 2, 3. It's more than one dimension and can be referred to as a matrix. So if you hear something referred to as a matrix, it's probably got more than one dimension. So see how a vector is just 1 row? This matrix has 2 rows. Then if we go down to A3, we're starting to get 3-dimensional here because we've got the axis going back here. This is where the n in n-dimensional array comes from. Now, it's very hard for us humans to visualize anything more than 3 dimensions, but in NumPy and with computers, you could have as many n's as you want. So this could go up to 4, up to 5, up to 6, up to 7. Depending on what type of data you're working with, you may have thousands of different dimensions. But if you hear axis 0, it's usually referring to rows. Axis 1 is usually referring to columns. And then axis n is usually referring to dimensions that are beyond just rows and columns. So this array here, or A3, would have the shape 2, 3, 3. Because there's 2 rows, 3 columns, and we've got 3 across here. So that's the final one here. And now, if n was higher, there might be more commas and this little shape would extend out here. Okay, so now we've got the anatomy of a NumPy array down pat. Don't worry, you can take a screenshot of this if you like. Otherwise, it'll be in the resources section. Let's have a look at some of the attributes associated with NumPy arrays. So the first one we'll take a look at is a1.shape. So it's 3, something. Now this is blank. Now the way NumPy kind of formats this data is that although we've said that the shape is 1, 3, NumPy kind of stores it without the row at all. So it's just got the 3 numbers here. That's just a little tidbit of how NumPy displays some kind of shapes. But if we have a look at the shape of A2, we can see that it's the same as what we've used in our anatomy of a NumPy array. And then if we go the same for A3, 2, 3, 3. Okay, let's have a look at a few more. So if we go A1.ndim, which is short for number of dimensions, maybe we do A2.ndim and A3.ndim. And what putting the comma here will do is when the code comes out, it'll just print it with commas spacing the 3 different variables apart. So this is number of dimensions. So A1, let's have a look at it again. A1 has a dimension of 1. We'll have a look at A2. Has a dimension of 2. And A3 has 3 dimensions. And so this is where the ND array data type comes in, is that these dimensions, depending on how complex your data is, could just keep going. And now the whole premise here, as we'll see some practical examples in the next couple of videos, is that whatever data you're working with, it somehow gets turned into numbers, and then a machine learning algorithm will find patterns in these numbers. Now, depending on what data you're working with will depend on how many dimensions there are. But let's not stop there. Let's have a look at the DType attribute. You might be able to guess what data type these are. Let's go here, Shift, Enter. So we can see in our A1 array, we've got ints. In our A2, we've got floats as well as ints, but it's going to default to float because there can only be one kind of data type. So it will automatically just turn the rest of the numbers in here into floats. And A3 is also just integers. We got a couple more. A1 size, A2 size, A3 size. We've got 3 elements in A1, we've got 6 elements in A2, and we've got 18 elements in A3. Now if we have a look at A3, that makes sense. Beautiful. So the size attribute tells us how many elements we've got total in our array. Now, we've got one last one, which is type A2, type A3. I think we've already seen this, but I'm going to get you to guess what it is before we hit Shift and Enter. 3, 2, 1. These are all ND arrays. So although they vary in size and shape, A1, A2, and A3 are all of the type ND array. Now this is an important concept to remember. No matter what type or what shape your NumPy array is, all of the functions and different data manipulations that you see throughout this section, if it's in a NumPy array, if your data is in an ND array data type, all of the things we're about to go through can be used on that. So that's a very important point to remember, is that the ND array is a universal data type, and it's very, very flexible. So now, to really exemplify NumPy being the backbone of other scientific data packages, that is, let's put a note here, create a data frame from NumPy array. So let's have a look. First, we'll import pandas as PD. Beautiful. And then we might create one from our existing array. So pd.dataframe. We're just going to pass it A2. Let's have a quick look at what A2 is. A2. Wonderful. So there's A2. Now let's see what that looks like. Oh, we need to view it. Shift and Enter. There we go. So this is a pandas data frame, and this is our NumPy array. So essentially, no matter what's in our pandas data frame, if it's all numbers, pandas is built on top of NumPy. So to represent our data as a data frame, it's just combining NumPy arrays in a formatted way. So that's a very important point to remember as well, is that once we start to get into the weeds of NumPy and start to work out what kind of numerical computing it can do, we can start to think, okay, so if we have some data and we import it in pandas, it's actually just a different combination of NumPy arrays. So if we want to perform some manipulations on it, we're actually just performing manipulations on different lists of numbers. All right, that's a brief introduction to NumPy's main data type. That's the main thing to take away from this, is that ND array, whatever array you have in NumPy, is of type ND array, and that pandas and other machine learning algorithm packages are built on top of NumPy, and machine learning is finding patterns in NumPy arrays. So with that being said, let's take a little break if you need to, go back and explore, create an array of your own by trialing it out. If in doubt, run the code, and I'll see you in the next video.